Design of light gauge steel frame for building structures with Frame CAD Structure. A tutorial series by engineer Siraj Biswas. Chartered Engineer, Institute of Engineers, India. Gold Medalist in Engineering Stream, University of Mysore. M.Tech in Structural Engineering, IIT, Delhi. Sun Certified Java Programmer, Sun Microsystem, USA.
This section we shall learn to provide bracing to the structure, that will be K bracing and the strap bracing. So K bracings are nothing but truss member which are diagonally placed between the logging member and two vertical members, and strap braces are tension member. They run from the top of the wall diagonally to bottom of the wall. So let us go to the B-set command first. B-set, enter. So panel brace type we have taken K brace, so that is okay. So let us start inserting K braces. The command for that is PIB, panel insert brace. So we should try to insert braces in a symmetrical manner so that there is minimum torsion created in the building and the torsion is within the limit. So click here, brace has been inserted. Click here, similarly click here, click here. So we have provided 4 braces here, so we should look for place for 4 braces here as well. 1, we can provide braces in the non-load bearing wall as well. 2, 3, 4. Now let us see where we can provide 1, 2, 1, 2. Then we have 1 set there, we can provide 1, 2. So there are 1, 2, 3, 4, 5, 6 braces on this sub, and we have 4 braces. 1, 2, 3, 4, 5 braces. 1, 2, 3, 4, 5, 6 braces on the other half. So PI is the command. Panel brace insert is the command for inserting bracing. So we should provide brace in such a way that braces are provided in a symmetrical manner and minimum torsion is developed. Torsion is developed in the structure because the first floor has a deck slab which is act as a semi-rigid diaphragm. So any discrepancy with respect to both sided number of bracing on the both sided would create resistance on one side more and resistance on other side more and subject the building to the torsion, which is the unraisable effect. So let us start with inserting brace. 1, 2, 3, 4. 4 here, then we should look for places for bracing here. 1, 2, we can provide braces within the non-load bearing also. 3, 4, then let us come back here. 5, 6, and here 5, 6. So we can provide braces here. 1, 2, 1. So we need to have one more here. Let us try here. 2. So now let us go to the other direction. 1, 2, 1, 2, 3, 4, 3, 4, then 5, 6, 5, 5 and 5. These are 5 and 5, 6, and let us put here 6. Oh, to match up, we have 1, 2, 3, 4, 5, 6. 6 braces here, and 1, 2, 3, 4, 5 braces here, including these 6 braces. So now we should always, we can provide some, we should always try to provide braces in a symmetrical manner, as I told you before, here and here. So this part doesn't have a wall in between, so I can provide a bracing here and manage similar to that. Now let us check the resistance developed by the bracing. The command for that is PCB. Now we see the resistance developed is 48 kN. This is the resistance in X direction and 53 kN in Y direction. So let us look for more A braces in X direction, so the resistance is similar in both direction. So we can provide one more here. PIB is the command. We can provide one more here. And here, now let us check for PCB. Now it is almost similar. So in addition to that, we will provide strap bracing that will see later. Let me see what is the wind shear at the top floor. The wind shear at top floor is 26 and 29, so 29 km. So both the direction, the resistance obtained is more than that. So still we will provide 4 numbers of strap bracing just to have minimum bracing, strap bracing in the wall because they are more effective in transferring the lateral load. They have more lever arm. Now let us see the seismic shear at the top floor. As when seismic shear at the top floor is quite low, it is less than, so it is on the top floor, it is the wind shear which is the governing force. 25 kilonewton is the seismic shear on the top floor. Let us go back to the frame CAD file and insert 4 numbers of strap bases on the top floor. For that we have to go to preset command again. Brace option, now make it single strap. Save. Now PIV is the command, PIV. So let us try for one brace here. And one brace here. And then for this wall, this is not able to create the brace. So let us try here. One here. This is also not able to create a brace. One here. And one here. So we have provided some braces as far as possible in a symmetrical manner. Now next step is to go to the ground floor. Now we will insert the K braces first. Again we have to go to preset command. Panel brace information. K braces, save. PIV is the command. So let us select one here, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 1, 1, 2, 2, 3, 3, 4, 4. Again here 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 1, 2, 2, here also 1, 1, 2, 2. Let us check the basing resistance here PCB. See, wind force is 89, wind force is 106, earthquake force is 112. Now earthquake force will adjust as per our calculation. The earthquake force should be 67.93, 67 kN/meter, and wind force in one direction is 57 kN/meter, in other direction 63 kN/meter. The wind force generated by frame CAD is more than what is being obtained from the Indian code. So we'll keep that. That will be on conservative side. If economy is demanded, we can reduce it by reducing the coefficient, but here we shall keep the forces generated by the frame CAD itself. To adjust the seismic force, we have to go to the B-set command. B-set, border setting command. Now here we have the earthquake force. So let us make this 40. Okay. Now let us make a PCB. Earthquake forces generated by this is 90 kN/meter. Let us reduce it further. B set. Let us make it 30. Okay. Now PCB. See, the earthquake forces is now lesser than what we got from 68 kN, so it is lesser here 67 kN, so we have to increase the coefficient a bit. B set. Let us make it 35. Okay. Now PCB. So earthquake force is 70. This is quite high. Move. Again go to B set. B set. Let us make it 32. Okay. Now PCB. 72 kN/meter, that's okay. 68, 4 kN more, so this is okay. Now let us look for position of strap basing. For that we have to go to P set, base panel, so change it here, strap bases, double strap shape. So let us try to insert a brace here. It is not possible, so let us try to insert a brace here. This is also not taking brace here. This is not taking any braces. Let us try here. Now we have got a place to insert braces here, but we are not able to get braces here. So let us insert a lot of K bracing here. So go to P set, P set, bracing for K bracing. Okay, save. Then PIB, PIB. Insert brace here. Insert a brace here. Insert a brace here. Brace here. Brace here. Brace here. So that will probably manage the resistance developed by these strap braces here. Now this is almost at the middle of the building, so if I provide a strap brace here, then it will contribute similar to both sides. So let us go to piece shape, brace panel option, double strap shape, then PIV, so now let us go to the other direction. We can provide a brace here, 1, 2, and then we have brace here, 1, 2. Now let us see this brace resistance provided. So shortage in X is 0 and shortage in Y is 4.9. So let us provide in Y direction. We have lesser resistance, so let us insert more braces in Y direction. So let us try here. Okay, we have got one. We have got one. Let us now check the resistance. So we have enough resistance in both the directions. So this resistance is including the sheathing resistance. So if we do not want this sheathing resistance to be included, we can go to pset command. So if we do not want the sheathing to resist the lateral load, actually the sheathing provides enough lateral load, but for this structure we will not consider the resistance provided by sheathing. So PCB is the command. Now bracing option, go to external plasterboard and uncheck them. Close. Now let us make PCB command. So plasterboard resistance is still open. So if you uncheck it, external plasterboard and internal plasterboard, the resistance is less than 100 km from the Y direction. So let us provide 2 more strap braces in Y direction. So P set. Let us change the base panel this to 65 degree. Save. Then PIV. It is not taking here. Not taking here. Try here. Yes. But for this all we cannot provide a double brace. So undo, delete these braces. We provide single braces because there is intersection of wall. It will be difficult to provide a double brace. So let us go to pset, brace option, single strap, save. Now PIV is the command, insert bases. So single bases has been put, the color is different, you can see. Now let us make a it is still bit lesser. Let us insert some A braces. Go to P set. Final information. A braces, save, PIV. One here, so that should be sufficient. Let us check it. PCB. So bracing makeup, bracing option, uncheck this. So bracing resistance 107. And design for lateral load is over. In next section, we will generate the detailed drawing of the wall panel and check if any wall is failing or any lintel is failing. If any wall is failing, then we can think of changing the stud spacing. If any lintel is failing, we can think of option of providing lintel plate to those opening. If any joist is failing, we can think of providing any joist any beam is failing, we can think of providing some extra reinforcement like a lee member or boxing the top chord and bottom chord. So before we exit, we save the file, save.